All right, so today we're going to talk about velocity time graphs. So the difference between a velocity time graph and a position time graph is that in a velocity time graph, we are going to graph the velocity versus time instead of graphing the position versus time. So instead of the slope being not the acceleration, instead of the slope being the velocity, the slope is now our acceleration. So in a position time graph, the slope is velocity. In a velocity time graph, the slope is your acceleration. So the easiest way to read a velocity time graph is just to read the graph. And if you read the graph, you can easily find the velocity. So if we look at the graph, and I'm just going to scoot it up here so we can see the whole page and the questions at the top. All right, so we're looking at velocity versus time. And the first question wants to know, what is the velocity when the time is 5 seconds? So we're going to look at our graph. We're going to find 5 seconds. And we're going to follow it. And the velocity at 5 seconds looks to be 25. If it's velocity, though, it's a vector. So we need to include our units and our direction. So 25 meters per second north. So the next question wants the velocity when the time is 7 seconds. So we're going to go to the graph and find 7 seconds. It's in between 7, right about here. And we're going to get the same thing. So the velocity is 25. Remember your magnitude, your units, meters per second north. When the time is 15, the velocity has increased. Our velocity is now 35 meters per second north. And at 25 seconds, we're going to go back up, and our velocity is again 25 meters per second north. The next question wants to know when the maximum velocity is. So the maximum velocity is just when the graph is the highest. So we're going to come down here. The graph is the highest between 17 and 20 seconds. And that maximum velocity is 40 meters per second north. All right, so the slope on this graph doesn't represent velocity anymore. The slope on this graph represents acceleration. So remember, velocity is a change in speed or change in place. So again, just a refresher from yesterday, slope is equal to rise over run. This graph is easier to read if the slope is positive. We are speeding up. If the slope is negative, we're slowing down. All right, so let's look at this question. It says, which time interval has the greatest acceleration? So we're looking for acceleration here. If it has the greatest acceleration, that means it has the greatest slope. So we're looking for the area of the graph that has the biggest acceleration or the biggest slope. And it says to calculate the acceleration for that time interval. So when we look at our graph, the steepest slope occurs between 5 seconds and 0 seconds. So the first thing I'm going to do is I'm going to write my formula for acceleration. So the formula for acceleration is is equal to the final velocity minus the initial velocity over the final time minus the initial time. So just from eyeballing it, I could calculate the slopes for each one, but we can look at this graph and see that this is your greatest slope. It's the steepest line. So I know my final time is 5 seconds. My initial time was 0 seconds. At 5 seconds, our velocity was 25 meters per second north. At 0 seconds, our velocity was 0 meters per second north. The zeros are going to go away. 25 divided by 5 gives me 5 meters per second squared, which is the right units for acceleration. My direction is going to be north. That also matches up with our graph. If we had gotten a negative, that wouldn't be right. And if we had gotten south, that wouldn't be right because we can follow this slope down here. If we wanted to count it out, we could count out the slope like you used to do in beginning algebra class. So it should be approximately 5 meters per second squared north. So our rise over our run should be about 5. That looks about right. 1, 2, 3, 4, 5. Looks about right. Looks like we're doing about right. All right, we're eyeballing that though. The second one, the next thing we need to talk about that we can get from this graph is we can get displacement. So velocity time graphs tell us a little bit more than a position time graph. Velocity time graphs not only tell us our velocity and our time, and we can calculate acceleration, but we can also calculate displacement, or how far we are from the origin. So we want to know the displacement after 15 seconds. So this area under the graph is our displacement. So all of this area together is my displacement. I'll use a black marker. And we're going to go back. I want to make this as easy as possible on myself. So we're going to go back to some basic tenets, some basic math, some basic geometry. If I'm going to find area, I would rather do squares than triangles. So I'm going to divide up this whole space beneath 15 seconds. I already had it highlighted. And I'm going to find a square in there. Because to me, it's easiest to find the area of a square. So I've divided it into 2 triangles and a square. I feel like I'm playing with tanagrams when you were little and you had to use all the little shapes to make the big shape. That's kind of what we're doing. And I'm going to label my 3 different triangles. So I have area of 1. I have an area of 2 that I need to find. And I have the area of this little triangle up top, 3. So if I was going to write out a formula that would give me displacement, I would say the displacement at 15 seconds is equal to the area of 1 plus the area of 2 plus the area of 3. All right, so now we need to find the area of each of these triangles so we can add them together. So let's do the area of 1 first. So to find the area of a triangle, your formula is 1/2 base times height. So my area of 1 is going to be 1/2. My base is 5 seconds. times my height is 25 meters per second. My seconds cancel. So my area of triangle 1 is 62.5 meters. All right. Now I need to look at the area of my second one. So the area of 2 is equal to length times width. Because it's a square. Remember I said I like those squares? So my length is 10 seconds. My width, again, is 25 meters per second. My seconds cancel. And I get 250. Oh, that's not 250. That's 250 meters. All right. And I don't have another shade of pink or purple. I'll use brown. We need to look at the area of triangle 3. That's all we have left. So I've already said that area of a triangle is equal to 1/2 base times height. So my area of triangle 3 is 1/2. My base is only 5 seconds here. My height is 10 meters per second. My seconds cancel, and my area is equal to 25 meters. All right, so now that I've figured out what A1, A2, and A3 are, what their area is, all I have to do is add those things together. So in my notes, I'm just going to draw a little box so I can differentiate. I did the math here to find the areas. Now I'm going to plug it in. So my displacement at 15 seconds is equal to 62.5 meters plus, I'm going to go down, please excuse me, 25 meters plus 250 meters. So my displacement is equal to 337.5 meters. So here's my final answer. So just a quick review. Velocity time graphs show us the relation of velocity and time. The slope shows us acceleration. So we're accelerating here. We're accelerating here. Our velocities are constant here and here. And this is deceleration, which means we're slowing down. We can find displacement on a velocity time graph by calculating the area underneath the graph where we're looking for the displacement. So at 15 seconds, she was 337.5 meters away from the origin. And that is all for today.